Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all in today's session. To access the notebook for today's session, you can access course page on my personal website arifbat.me. The other way is to download all the notebook files from course GitHub account Arif.18, and all the notebooks for this course are housed in this public data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture number 6.18 of the 6th module, Machine Learning, for the course titled Tools and Techniques for Data Science. Well, my dear students, in the previous sessions, we have gone through all the nitty-gritties of building machine learning models, including different pre-processing tasks, as well as designing machine learning pipelines. In today's session, and maybe in the next session as well, I will give you a step-by-step practical implementation of how to deploy a trained and evaluated machine learning model. So let's move on to the agenda for today's session. Instead of straight away jumping on to different ways of deploying a machine learning model, I will give you around a 20-minute practical recap of all the phases of a machine learning lifecycle. This will be a quick hands-on practical summary of what all we have covered so far. So after understanding the problem at hand, the first step is data acquisition. That is, we acquire the data. We then carry out analysis by performing exploratory data analysis and do different data pre-processing and feature engineering tasks. We then choose the right estimator or machine learning model for the problem at hand. Then we create a pipelined model. We do a train test split with a holdout set. We fit or train the model on the training set and evaluate it using test set, preferably using some cross-validation technique. We then try to optimize the hyperparameters using grid search or randomized grid search techniques. And once we are completely satisfied with the performance of our machine learning model, we evaluate it using the holdout set for reporting purposes. Finally, my dear students, we retrain the finalized model on entire dataset before we actually save or serialize the model and all the related components in a pickle file using Python's joblib or pickle module. My dear students, we have performed all these tasks step by step, covering all the concepts in our previous session in a reasonable amount of detail. But today I will quickly repeat all this and finally create the pickle file of a machine learning model which we want to deploy for a crystal clear understanding of machine learning model deployment. And if this is just a repetition for you, please feel free to move on to section 2 by clicking the timeline in the description box below. You all know that deploying a machine learning model means to make the model available for the end users, which can be human or maybe they can be some application program, in which case we need to build an API of our machine learning model. Well, model deployment is one of the last stages of any machine learning project and can be a little tricky. My dear students, I have divided this deployment part in further 3 sections, which we will cover today, inshallah. In section 2, I will make use of Streamlit library that allows you to build a simple data-driven web application for our data science and machine learning projects. The main advantage of using Streamlit is that you need not to have much knowledge of HTML, CSS, and JavaScript for UI design. In section 3, we will create a web app using Flask, which is a web application framework written in Python. And of course, we will use HTML and CSS for developing our front end. In section 4, we will create an API using which, instead of human users, other application programs can access the functionalities of our machine learning model. My dear students, today we will learn all these techniques to deploy our saved machine learning model in our local machine. Inshallah, in our next session, we will extend by deploying our machine learning model using some cloud service like Heroku, Microsoft Azure, or Amazon Web Services. We have lot to do today, so let's start playing. My dear friends, let me start with a quick recap of all the phases quickly. Our journey started with the problem understanding and data acquisition phase. We explored different data sets that comes bundled with uh, libraries like Seaborn and Scikit-learn. We also explored some real-world data sets available in public dataset repositories like kaggle.com, data.gov, and UCI ML repository. We also scraped data from websites using Beautiful Soup, Selenium, and Scrapy. You can get a company's data from SQL or NoSQL databases or from IoT devices and get help of different crowdsourcing services like Amazon Turk and LineBridge AI. Before we move on to the section 2 of today's lecture, where we will learn different tools and techniques to deploy a machine learning model, let us build a model in this section. So over here, I'm just importing certain libraries, the required libraries, and then I am loading our favorite advertising dataset. Having three input features, specifying the company's expenditures in 1,000 rupees on TV, radio, and newspaper advertisements, and the corresponding sales of items in 1,000 units. The dataset has total of 200 observations. The task is that given a new budget of an ad campaign for TV, radio, and newspaper, our model should be able to predict the sales. Okay. My dear friends, once we have the data, the next task is to carry out exploratory data analysis, which can be univariate or multivariate, to have a clear understanding of the data. We have been using Matplotlib and Seaborn library for this task, and we have spent a reasonable amount of time on EDA of this advertising dataset as well as many other datasets. So let me just move ahead. Interested students can watch video lecture 6.6 for details. And let me just show you the relationship of these by using the pair plot method of Seaborn. So we have gone through with all this. Let's move ahead. Okay. After EDA, the next phase is data pre-processing and feature engineering. In this phase, you keep those features which play a role in the prediction of the output label and drop the remaining unnecessary columns. In the advertising dataset, we have decided to keep all the three input features. And the six common tasks we need to perform in this phase are handling outliers, imputing missing values, encoding categorical features, feature scaling, extracting and combining information. Let me just check out the data types. So all the four columns, the input as well as the output labels, have a data type of float 64. Let's check out the null values as well. And using the isNull method on data frame, and let me call sum on it as well. So we do have missing values under the TV, radio, and newspaper column. My dear friends, we will do two pre-processing tasks on this dataset: missing value imputation and data scaling. We normally do the pre-processing over here, but once we are satisfied with the performance of our machine learning model, we perform all these steps in the pipelined version of the model before deployment. And since we have done it many a times in our previous sessions, so I will do all the pre-processing while creating the pipeline version of the model. So let me move ahead. And once the data is ready to be fed to the machine learning model, and of course, the next step is to choose the right estimator or the right machine learning algorithm for the task. And the right model for your data depends on the type of the data you have and what you want to do with it. Well, this scikit-learn library provides this flowchart as a rough guideline to choose an estimator to try on your data. And of course, before applying linear regression, which we are going to apply on our advertising dataset, we must ensure that our dataset satisfies these four assumptions of linearity, independence, homoscedasticity, and normality. What do we mean by these assumptions, how to determine if these assumptions are met, and what to do if any of these assumptions is violated. We have discussed all this in detail in lecture 6.6 and have concluded that linear regression is an okay algorithm for this advertising dataset. In most of the cases, we try different models, and whichever give us the best result, we choose that as our final model for deployment. Okay. My dear students, next step is to create a pipelined model. A pipeline model, train it, evaluate it, and then try to improve its performance via hyperparameter tuning. We have discussed pipeline models in detail in lecture 6.16 with a lot of examples. I assume that you have watched that session or already know how to create a machine learning pipeline, which is just a series of steps that you follow while working on your project. A machine learning pipeline could include things like acquiring and pre-processing your data, training, hyperparameter tuning, and validating your models, and finally deploying them to make predictions. And for our advertising dataset, this is a simple pipeline model that we want to create, having two transformers, a simple imputer and a standard scaler, and finally an estimator, which will be a linear regression model. And this is the code cell that creates an instance of this pipelined model. And if you don't understand the code, please watch 6.16 session for detailed discussion on the machine learning pipelines. It's very simple. I have just created a pipeline model using the pipeline method. These are the steps, and each step is a tuple having 3 values. Okay, let me just execute it. Once this code cell executes, we have an instance of a pipeline model in the variable named piped_model. Well, my dear students, now we have an instance of the model. We need to train and evaluate it. Instead of doing a simple train test split, I am doing a train test split with holdout set and evaluating the model using this 5-fold cross validation. And this is described in this image. Suppose this is our 200 observations of advertising dataset. First, I will do a train test split with a test size of 10%. So I have 180 observations for the training the model, and 20 observations are in the holdout data. And this is the data which I will never touch while training and hyperparameter tuning. This will only be used once I am completely satisfied with the performance of my model and want to check as to how it will perform on completely unseen data. Okay, after this I will do a train test split on this training data with a test size of say 20%. And if I have 180 observations in this training data, I will have 144 observations on the training data and 36 observations in the test data. Now I have two options to train and evaluate my model. One is I simply train on these 144 observations and evaluate on these 36 observations. And we all know that the limitation of this train test split technique is that we are evaluating our model on only 20% of this data. It would be far better if we can evaluate our model on these 144 observations as well. So better to use some cross validation technique. And over here, I'm using 5-fold cross validation. That is, instead of splitting the dataset into a single train test as shown over here, we repeatedly split the data into 5 multiple train test splits. In this image, I have done 5-fold cross validation. The model is trained and tested on each fold, having different test or validate set. For each fold, we get a R2 score, and the mean of the 5 R2 scores is considered as a true evaluation of the model on this training dataset of 180 observations. And once we are done with selecting the model as well as tuning of its hyperparameter We evaluate the finalized machine learning model with its final hyperparameter values using this hold out set for the reporting purposes. My dear students, I have discussed this topic in detail, this cross-validation topic and hyperparameter tuning in lecture number 6.14 and 15 respectively. So if you are not clear, please, I strongly recommend that you watch those two sessions. Now let me perform all these using the Python code. Okay, so over here in this code cell, I am simply separating out the input features in X and output labels in Y. Okay, and over here I am doing the first train test split that separates the training data and holdout data of 90-10. I'm doing this train test split, 180 in the training set and 20 in the holdout set. Let me execute this, 180 and 20. And once again, I'm doing a train test split. And this is the second train test split that do the validation split of 80-20 as shown over here, 144 and 36, 80-20 split. Let's check out. Great. I hope this makes sense. Okay. Now we have our training data. We can call fit method of the pipeline model by passing it the X train and Y train. Let's just execute this. Good. My dear students, remember when we call this fit method on this instance of pipelined model having two transformers and an estimator, the fit method of both the transformers as well as the estimator has been called, and we have now the trained pipeline model. Let's now evaluate. We can evaluate using the simple validation split or using cross validation. Let me show you the image again. So this was the validation split, and this is a preferred way of evaluating your model using 5-fold cross validation. So let's see this in code over here. Yes. Let me just evaluate this. So this is the evaluation R2 score, and over here I'm doing the cross val score. I'm computing the cross val score over here. Okay, let me execute this and this. Fine. So we have got an overall R2 score of 0.904. And of course, this is not the true evaluation of our model as discussed. Over here, I'm using the cross val score method to perform a 5-fold cross validation. This CV is equal to 5. And you see over here, I am getting 5 different R2 scores, 1 for each fold. And over here, I'm just computing the mean of it. And you see that the mean R2 score is 0.785, which is far less than the R2 score computed above over here. But this 0.785 is the true evaluation, because this time it is evaluated on the entire training data set. Good. Okay. My dear students, I'm just skipping this step of improving our model via hyperparameter tuning to spend time on today's actual topic, which is model deployment. Interested students can watch lecture 6.15 where we tuned the model hyperparameters. We did that manually using loops, as well as we use grid search CV and randomized search CV. Let me move ahead. Once we are satisfied, my dear students, with the machine learning model and its hyperparameters, to test how the model will perform on completely unseen data, we need to evaluate it using the holdout data set, which is there in X underscore holdout and Y underscore holdout. Let me just execute this. Great. We will submit this report to our project manager or maybe the client, which says that on completely unseen data, this model will predict the sales with uh, a root mean squared error of 1.347 and an R2 score of 0.9038. Great job done. Well, my dear friends, before we make a binary of this pipeline model for deployment, it is a normal practice to train or fit the model on the entire available dataset. That is the complete X available to us and the complete Y. Let me just execute it. And remember, there is no going back now. Let's save the model. Final step, that is you just save the model and anything else you need as a job lib or a pickle file. Let me just execute it. So we have saved the model. Let me just check out where it is saved. Well, it is saved in the present working directory, this lr underscore model.pkl. Now let's suppose that I have given this pickle file to a fellow developer of mine to do the prediction, and he or she will of course use the load method of joblib module to load the trained instance of the pipeline model. And suppose the fellow developer wants to predict the sales of a company who spends 60, 50 and 40,000 rupees on advertisement of TV, radio and newspapers respectively. And moreover, suppose mistakenly for the newspaper of the data entry operator has missed the value and I have placed a NaN over here. So finally we call just the predict on this loaded machine learning pipeline machine learning model. And of course you see that I have passed it three values, two values, one is missing. Let me execute this code and the result is 14.98. So the predicted sale amount is 14.98 units of the items, rather 14.98 thousand units of the items. Great job done. Okay. My dear friends, this was more or less a precise summary of what we covered in our previous sessions. Now the next and the final phase of machine learning model is deployment, which we will do using three different ways in today's session. First, using Streamlit library, then using HTML, CSS and Flask, and finally I will give you a flavor of deploying your model as an API to be accessed by other programs. Let us start with the easiest and the fastest option, and that is using the Streamlit library. And let us visit the official website, and that is streamlit.io. My dear friends, Streamlit is a Python library that allows you to build a simple data-driven web application for your data science and machine learning projects. Streamlit actually adds a UI interface in a Python script without any need of coding in Flask or Django, and there is no need to have any working knowledge of HTML, CSS or JavaScript. Let me just click this gallery link over here, which contains many awesome applications of Streamlit that were built by user community. Here are the different categories. And let me click education, and in education we have this Python stat tools, which is an app built in Streamlit that teaches about basic statistic principles through a variety of graphing parameters. You can view the source code that is available on GitHub, as well as you can click this link, go to app, to run the application. Which is deployed in the community cloud of Streamlit. This may take a few seconds to load. So it's loaded. So over here, you just mention the public Google Sheet URL. And once you click the refresh button, the data is loaded in this data frame. And right now, this data frame has 4 columns: group, gender, height and weight, and I think a total of 100 observations, 0 to 99. And let's see the histogram of the height column, and let me set this color to none, and let me just improve or increase the number of bins to 17. You can see how interactive this is. And in this table over here, you can see different descriptive statistics of the two numeric columns, like min, max, mean, standard deviation, and quartiles. Let me click this option in the graph settings. Let me click this scatter plot to change the graph settings. Now instead of histogram, you can see a scatter plot between height and the weight column. Let me click this linear regression option button over here. It has now applied simple linear regression by keeping the height along the x-axis, that is independent variable, and weight along y-axis, that is the dependent variable, and computed the slope as well as the y-intercept. Let's scroll a bit down and you see it has drawn a scatter plot with the best fit line. It is also giving me the option to predict the weight of a person given its height. Let me predict the weight of a person having a height of, let's suppose, 60 inches. I've entered 60. Let me press enter. And it says the weight is 146.92 pounds. So for 60, the weight is roughly 146.92 pounds. Great. Moreover, you can give an alpha value of your choice to change the confidence interval. Anyways, my dear friends, do make time to explore this and the other applications of your choice. It will be fun and will give you insights about the power of using Streamlit to build such applications by writing far less lines of code. Let me go back to the Streamlit homepage. Streamlit.io. Okay. So this is the home page, and let me click this documentation link. Well, it is a very comprehensive page. In the left pane, you can see links to different Streamlit library, as well as you can see links to Streamlit Community Cloud. Let me click this plus icon with the getting started, which tells you about installation of Streamlit and setting up the Python virtual environment. The main concepts inside your Python script, actually you use the Streamlit widgets as per your requirement, and then instead of executing your .py script using Python interpreter, you use Streamlit run command to run the script, and this is all shown over here. Let me just scroll down to the bottom of this page to over here. Okay. The app model. Do read these points to have a clear understanding as to how the overall Streamlit application work. These are just Python scripts that run from top to bottom. And every time a user opens a browser tab pointing to your app, the script is re-executed. As the script executes, Streamlit draws its output live in the browser. And the scripts use the Streamlit cache to avoid recomputing expensive functions. So this is very fast. And every time a user interacts with a widget, your script re-executes, and the output value of that widget is set to the new value. And it can contain multiple pages which are defined in separate .py files. Anyways, let me come up over here now. Let me close this. Okay. Fine. So this API reference, write the call. So we have the write command, the most common command that you use. We have different other commands to create different types of text elements. You see, title, header, subheader, caption, and so on. and we have a variety of different display elements like data frame, table, and so on. We have different charts, line charts, area chart, bar chart, and so on. We have a lot of input widgets like this button, this checkbox, this radio box, and so on. We have media elements for the audio, image, and video data. I think, my dear students, that is enough kickstart on overview of Streamlit. Let us now make our hands dirty to use it and to create a simple web interface for the advertising machine learning model that we have built in a section 1 of today's session. Let me move on to VS Code now. So VS Code is already up and running. My dear students, I have spent one complete lecture on VS Code, the previous one, I think. So I hope you have a fair understanding of its working environment. If not, I strongly recommend that you should watch that session. Well, anyways, in the left, excuse me, activity bar, let me click this Explorer icon and click this open folder, this open folder button to open my project folder, which is there in documents, data science course, Arif notebook files, section 6, and over here I think it is 6.18. Well, this is the project folder in which we are going to work today. So let me click open. You can see we have lecture 6.18 Jupyter notebook file, and we do have the lr underscore model.pkl file which we have just created. Let me just open this Streamlit directory, and this Streamlit folder now has only one file, that is streamlit app.py. Let me click this. So this is hardly a 15 lines of code that will do our job. But before I describe and execute this code, let us install Streamlit. You can create a new virtual environment for this project and then install all the required libraries as we have done in a previous session of VS Code. But for the time being, let me use the base environment. Let me just open the terminal. Okay. Let me use shift to the Streamlit directory. Right now I'm inside the base environment. If you are not in that, let me show you how you can come to that. So if you get a prompt something like this which doesn't show any environment, you can just say conda activate base. If the virtual environment has been created using conda, you use this command, and if you have created it using python-m command, you just execute the appropriate activation script. Anyway, so let me just do ls. We have streamlit app.py over here. Let me use pip install Streamlit. I have already installed it, so it says that the requirements are already satisfied. Let me clear screen, and to verify, if you want to verify, let me say a hello to Streamlit, and I can do that using Streamlit space hello and press enter. You see, this will execute a Hello Streamlit application in your default browser. In the left pane over here, you click these different demos. Let me click this animation demo. Let me click this plotting demo, which illustrate a combination of plotting and animation with Streamlit. And of course, you can view the code as well. Simple. Let me just close this, fall back to this, press Ctrl C, clear the screen. Okay, now it's time to go through this Python script file. Let me close this. Okay. The first three lines over here, they're just importing the required libraries. Note the alias of Streamlit that is most commonly used as ST. Over here, I am loading the serialized machine learning model that we created and saved in lr underscore model.pkl file using the load method of the job lib module. And these four lines of code are actually setting a title of the web page and creating three text boxes for numeric input to get the advertising budget of TV, radio, and newspaper. Please do go through the documentation where you will see all these methods. Then I'm using these three scalar values that I have received from these inputs to pandas data frame. And since I am using a dictionary of scalar values, so I have to pass this 0 to the index argument as well. Now we are all set to predict by calling the predict method of the model and passing it the data entered by the end user. And this should happen only when the user presses the predict button. This condition st.button, this method will return true if the button was clicked on the last run of the application and false otherwise. When this web application will run for the first time, this line will be displayed because the button is not clicked. And when the user will click the predict button, this condition will return a true, and these three lines will get executed. Hope this code is clear to you all. Now it's time to just run it. Let me just open the once again, I am out of it. Streamlit. Let me say Python. Oh no. Once you need to run this Python script in which you have used Streamlit, you don't run it using Python. Rather, you say Streamlit run and the name of the Python file. Oops. Okay, so we have some issue with the environment. Let me do it again. Conda deactivate. Let me do it again now. Stream let run. Okay, great. Now this is the beautiful interface that has just been created by these few lines of code. Note this title, advertising budget prediction. This is the title. Note these three input boxes. These are the three input boxes. And once you execute it, note that this Streamlit application is running on your local host at port 8503. Okay, let me just enter this piece of values. Let me say 60,000 for TV, 50 for radio, and let's say 40 for newspaper, and let me press predict. Remember, my dear students, right now, since we have not click this button, so you are getting this enter add budget and click predict button, and this is this string. Okay, and once I will click this predict button, these lines will get executed, and to our model predict method this data will be sent, which will return the result, and this string will finally be there. and let me just click, and you see 14.97. Great job done. My dear friends, I hope this is clear to you. Let me close this and this and this as well. Let me fall back over here. Let me press Ctrl C to stop it. Let me close this. Let me close this. Great. My dear friends, now let us deploy the same machine learning model but using Flask this time. Let me open this Flask folder now. Instead of straight away jumping on the code inside VS Code in these files, let me give you a quick but informative theoretical background of Flask project. So let me move on to the browser, come up over here, and let me say, let me just click Flask documentation, and let me click this. Okay, simply speaking, Flask is a web application framework written in Python that is based on Jinja 2 and WSGI. Let me just click this Jinja 2 documentation link, and let me just click this introduction. Do go through the details. In simple words, Jinja 2 is a web templating system that combines a web template along with a certain data source and used to render dynamic web pages. Let me just click this back arrow twice to fall back over here. And let us now go to this workzig documentation, which is a utility library. This is a utility library for WSGI. Do go through this documentation, but for the time being, let me simply tell you what is WSGI. Let me just click and open the search bar and say, let's say, what is WSGI? Liquid web. Okay, I think this is good. Okay, let me open this link. No, this is not the one. Let me open this one. Okay, fine. So WSGI stands for Web Server Gateway Interface. It is used to forward requests from a web server like Apache or Microsoft IIS or maybe Nginx to a backend Python web application. The web application then generates a response and send it back to the web server, which further send it to the requester. And hope this image is making this clear to you. Let's just fall back to this workzig documentation page, and let me click this back arrow to go to Flask. My dear friends, do make time to go through this documentation page containing installation instructions, tutorials, and quick start. And let me just click this routing link over here. This is important. I just want to touch upon. My dear students, the students who are following this entire series of lectures must be knowing about decorators. Let me revise. A decorator is actually a design pattern in Python that allows a user to add new functionality to an existing function without modifying the structure. Quite complex. Anyway, today in our code, we will be using this route decorator to bind a function to a URL. It is passed actually two arguments, a URL and the options. But these two examples over here, they are using just one argument. So this is the first route. / is bound to this function index, which will return this string. And this second route / hello is bound to this function hello, which will return this string. And of course, it can render some HTML file and return that as well. Soon we will see this practically. I think that is enough theoretical background. Let's fall back to VS Code to understand this practically. So first thing first, let us install Flask. Let me once again open the terminal. I don't know, there is some issue with my Conda environment, due to which I have to Conda deactivate. Okay, now it's okay. I'm in the right environment now. Once again, I recommend you to create a new virtual environment for this Flask project and install all the required libraries over there. But right now I'm just using the same environment that in which we are working on. Pip install Flask. So this will install Flask. I have already installed it. So it says that requirements already satisfied. So I am inside the directory Flask. It has application Python file app.py and a directory templates. Fine. Let me come up over here in the Explorer panel inside the Flask folder. And inside the Flask folder, let me create a new file temp.py. Inside the Flask folder, let me create a new file temp.py. So this is just a Python file. And let me write a hello world Python app step by step that uses Flask, and after that I will move up to the discussion of this code, that is app.py. So let me just first import Flask class from Flask, import Flask with a capital F. Okay, let me now create an instance of Flask class by calling its constructor Flask and passing it name underscore underscore. My dear students, underscore underscore name underscore underscore is a special built-in variable in Python containing actually the name of the module in which it is defined. Let me just assign this instance to a variable named app. Good job done. Now we have the app variable. Let me now define our route decorator with the URL of root. In our case, that is localhost. Let me say at app.route, and let me just give a / to this. And let me associate a function to this, bind a function with this route, and let me say name it home. You can name it whatever you feel like. And let me simply return h1 tag, something inside the h1 tag. Let me say h1 and let me say Flask, hello Flask, and let me close this h1 tag. Okay, great, done. Now, my dear students, if you run this script it should execute all this, and if you want to do it only if it is executed as a script and not as an import statement, then you should write something like this: if underscore underscore name underscore underscore double equals main underscore underscore. If this is true, only then you say app.run. Remember, this condition will evaluate to true only if this file is executed as a script, and this will evaluate to false when this file will be executed, rather when this file is imported in some other module. Okay, I hope we have talked about this in some previous session. Great. Let me just save it, Control S, so it's saved, and let me come up to the terminal, and now we run it this temp.py file. Let me press enter and it say name is not defined. Okay, so we have two underscores over here. Let me execute again. Great. So when we execute this script, the underscore underscore name underscore underscore variable contains string underscore underscore main underscore underscore. And this condition evaluates to true. And this run method of the app is called, which will run a development server on localhost at port 5000. Let me just copy this URL, come up to over here, write it over here and press enter. And voila, you have your Hello Flask. So this is what this has returned. Let me make a change in this Python script. Let me remove this sign of exclamation and put some periods, save it, come back over here, refresh it, and you see there is no change. So the change is not reflected over here. You have to actually stop the server and run it again. You have to stop the server by pressing Ctrl+C. A better way is to pass debug is equal to true. Over here in the run method, you say debug equals true. Just save it. Run the server. Come up over here. Execute. Come up over here. Make a change. Hello Flask with Arif. Save. You see there is a watchdog for file system events and the debugger is active. If I come up over here and I refresh this, it is changed. Great. Well, now instead of returning simply this HTML string, let me return a rendered HTML file. So just let me just comment this line. And instead let me say return render underscore template and let me give the name of the file hello underscore flask.html. Suppose that this is hello flask.html is HTML file and I want this function to render the code of this file and return this as a response. So this render underscore template method will do this job. This render underscore template is a method of Flask module. So let me import it over here. Render underscore template, and let me save it. And let me just close this over here. My dear friends, this render underscore template method is used to generate output from a template file based on Jinja 2 engine that is found in the application's template folder. So we need to keep this hello underscore flask.html file under this templates folder. So in the Explorer panel over here, let me create a file hello underscore flask.html. So this is a file, and let me just create a HTML boilerplate using a shortcut, and you can do that using HTML:5, press tab. Great. And let me just give a h1 heading in the body over here, and let me say over here, let me say h1, and what I need to write is just a hello world, and let me say h1. Let me save this. So this is file that is saved in templates folder. Let me come up to temp.py and let me execute it again, and let me now press command and click this. So we are over here, and if I right click over here and I just view page source, You see, this is the code that we have just written. Great job done. Great job done. Let me close this and this and this. Fall back over here. Let me close this by pressing Ctrl plus C. Okay, so let me close this temp.py file as well as this. My dear students, I think now you are ready to walk through the code using which we will wrap our machine learning model inside a Flask app. And remember, for that, we have this app.py file. So we have this app.py file, and the other file is there in templates folder, and that is index.html. Let me create this, open this app.py file. Okay, so let me talk about this app.py file. Let's talk about this index.html file first. So this is, I don't want to do this. I just want to open this index.html file. Okay, so this is the index.html file. Note that inside the form element over here, this is the place of our interest. Inside the form element, I am using the input tags to get the advertising budget for TV, radio, and newspaper. And we do have a submit button. And what else I just want to talk about? Yes, this action attribute. Note this action attribute of the form element. This specifies where to send the form data when the user clicks the submit button. And similarly, do note that the method attribute is set to post. After this form element, at the very end, we have this h4 tag. This is the placeholder for the prediction text that will be sent back by our Python application. So if I just summarize this index.html file, the end user will fill up the form, press the submit button. The data will be sent to the Python app, which will use the machine learning model to do the prediction and return the results, which will be displayed over here. Okay, let me come up to the app.py file now. Fine. Once again, the first initial 3 lines of code are just importing the required libraries. At line 6 or 7 over here, I'm instantiating an object of Flask class. Over here, I am loading the saved machine learning model. And these 3 lines are actually creating a route decorator, which will tell the Flask application which URL to render next on the web page. When the Flask server will run, the Flask application will route to the default URL path, and that is just / and call the home function, which will return the rendered index.html file to the server. Excuse me. And of course, the same will be returned to the client, which will be a browser program in our case. Now, over here, these 4 or 5 lines of code, this is another route decorator. Let me describe these lines one by one. Note the route method is post, and it is passed 2 arguments. The first is the just the URL, and that is, this time it is / predict. And over here you can pass a list of different HTTP methods. I have used post over here, which is used to send HTML form data to the server. For example, in this case, the user is going to enter values of TV, radio, and newspaper advertisements in the form, and when the user clicks the button, the data is sent to the server. Well, this predict function will execute, and if you see this line is using list comprehension to read all the values of the form, typecasting them to float and unpacking them to these 3 variables. Then over here, I'm just converting the values to a data frame and passing this data to the predict method of the pipeline model, our loaded machine learning pipeline model, which will return the predicted sales of items in this variable result. And finally, over here, I'm again using the render underscore template method and returning the index.html file along with a string that specifies predicted sales of items in thousands is this much, whatever is the result. Okay, fine. And let me now come up again to this index.html. Uh, uh, this is the placeholder prediction underscore text. So for the very first time, it will be empty, and once the user enter the data and press this predict button, the Python app script will return this index.html, but this time with the prediction text as well. Let's fall back to app.py. And finally, over here, once again, I'm calling the run method of the Flask app object if this .py file is executed as a script and not imported as a module. Let me come down to this terminal and say just python app.py. Remember, I'm running it from the base virtual environment where I've already installed all the libraries. Let me just press enter. Let me just move on to this 127.0.0.1 at port 5000. So great. So this is the index.html file. Let me just enter the data and say, let's say 50, and over say, let me say 40, and for newspaper let me say 30, and let me click this predict button. Voila, we have got the predicted sales, and that is 12.66. Great job done. Let me close this browser tab, come back over here, and let me close this one, and let me press Ctrl C to close the server. Great. My dear students, we are now done with the first two techniques. The first was using Streamlit, and the next was using Flask. Now it is time to create an API and deploy it. Let us first see what is an API. Let me once again open a browser and let me say what is an API and its types. Okay, and let me click this. Okay. So my dear students, API stands for Application Programming Interface, that allows two applications to interact with each other without any user intervention. And we all know that Google provides a dozen of APIs which your application programs can access, like the Maps API, Language Translation APIs, and so on. Similarly, Twitter API gives you programmatic access to the core elements of Twitter, like tweets, direct messages, users, and so on. Now we are going to write an API in Python that will send the advertising budget in JSON format, and it will return the sale prediction. Let me go down a little bit. Okay, do read it at your own time. Okay, well, over here, these are some of the API testing tools. We will use Postman for testing our API. There are different types of web APIs, my dear students, like RPC, SOAP, GraphQL, and REST. The most commonly used these days is REST, that stands for Representational State Transfer. My dear students, let me open another browser over here, and let me say Postman. This Postman actually is a API testing tool which I'm going to use. Let me press enter. Okay. You can of course create a free web account and use Postman on the web, but I have downloaded and installed the Postman app. You can also download and install it on your machine, and then we will create an API and we will test it using this Postman. Let me just fall back to VS Code. In our Explorer window, once again, you see three directories. We are done with deploying the machine learning model using Streamlit and Flask. Let us now write a Python script to create an API for the same task. I have already written this API that is there in my API directory. Let me click this api.py. Let me give you a quick walk through this code. It's simple and easy to understand now. As usual, the first few lines of code are importing the required libraries. Then I'm creating an instance of Flask app. After that, I am just loading the saved machine learning model in this variable model, and here is the route. I'm creating a route decorator as done before and passing it the URL and the post method. You see this predict method or function is receiving the JSON object. And converting it to the pandas data frame, and then passing it to the predict method of the loaded machine learning model, and finally this predict function is returning. Well, this JSONify method of Flask returns a response object as JSON, and of course this if structure, if true, will call the run method of Flask app object, and this condition will, as you all know by now, will evaluate to true if this .py file is executed as a script and not imported as a module. Moreover, do note that we are specifying the IP as well as the port number to the run method this time. So this time the server will run on this IP, that is 0.0.0.0. This is the IP that is used for all the IP addresses of this computer, and the port is 12345. Let me just execute this. Let me just say oops. So we have some issue over here once again with this terminal. No. Yes. Let me close it, open a new terminal without wasting much time. And as usual, I again have to do conda deactivate, sorry for this, and conda activate base. And let me just say Python api.py. So this time I'm executing this script file. So you see it is running now, but this time it is running on 12345. So this is the address. Let me just copy this. Great. So the Flask server is running and waiting for a JSON request to be sent to the API. Let me this time use a Postman to test this API. My dear students, you just run the Postman. I am already running it on my machine. You just click this new, and let me just create a basic HTTP request. Select the HTTP method. We are using post. Enter the URL, and that is 127.0.0.1 or maybe 0.0.0.0, and the port number is 12345, and remember predict. So this is the complete URL, and now I need to create a body. I need to send the JSON file. Let me just click raw, and over here let me select JSON, and let me just write down this TV. The value of TV is, let's suppose 60, comma radio, and the value of radio is, let's suppose 50, comma newspaper, and let's say the value of newspaper is 40. So this is the zoom. So this is a JSON file. This is the data on which I just want to run my machine learning model. Great. Now let me just click this send button. Once I click this send button, my dear friends, you get a response over here. And the requested URL is not working. Let me just check out, change it to 0.0.0. 1, 2, 3, 4, 5, predict. I think it should work now. No, it is not working. I don't know why. Let me come up over here, close this, run it again. Python api.py, run it. So these are the address 1, 2, 3, 4, 5. It's working fine. HTTP colon 1, 2, 3, 4, 5, and we have this predict, predict, and the method is post. This is the data in JSON, and let me use send. Okay, my dear students, let me find the reason of this. I don't know. I don't see any reason. Can anybody help me for this? This is of course raw, and we have selected this. TVs, radio, there is no typo, things seems fine, and it says the requested URL was not found on the server. Okay, so there is an issue with the requested URL. Let me try this. Copy, come up over here, paste, slash, predict, click send, and great. So there was some issue with this. So my dear friends, once again we have got the prediction 14.967. Great job done. Alhamdulillah, dear students, we are done learning the deployment of machine learning models using Streamlit library, another Flask application, as well as an API, and we have tested that API in using the Postman application. Well, if you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning, and Allah Hafiz.